Hello everyone, this is Prajwal Kamath, a member of the BMSIS 2024 cohort, and the title of my project is Universal Signatures of Life. So let's get started. An overview of the presentation. The first part will be covering the introduction, the second, the overall goal of my research group, and the last three portions would cover my work in detail. So how can information theory help us in deciphering extraterrestrial life? There exists a strong possibility that extraterrestrial life may be compositionally distinct from terrestrial life. That is, it may not be carbon based, or it may not subscribe to the preconceived notions of life which we hold on to. So, our measures need to be both unbiased and broader in their approach. What are the distinct signatures of evolved species? Our research group tried to collect a wide variety of time series data associated with physical, biological, and technological processes, which was then pre-processed by using Fourier transform and decomposed into a combination of sine and cosine waves. And a chunk of oscillations of the maximum frequency or the frequency which repeated itself over and over again in the data was taken and subjected to a variety of complexity measures like transfer entropy, Jensen-Shannon divergence, and statistical complexity. My focus was towards understanding the complexity of brain, which has been the product of years of evolution and a center for information collection, processing, and transmission. EEG, or the electroencephalogram, measures the electrical activity of the neurons in the outer layer of the cerebrum and can be measured by placing electrodes on the scalp, like shown by the infographic on the slide. Are the regions of the brain interconnected? We try to understand the dependency of electrodes or regions of the brain upon each other, for which we calculated transfer entropy, which measures the amount of information flow from one time series data to the other. For example, if we have two time series data, X and Y, and wish to understand how the past of Y influences the future of X, given that we already know the past of X, this can be done using transfer entropies, or in other words, how much Y's past predicts X's future beyond what is already known about X's future from the past of X. So these are the transfer entropies of different regions of the brain. So y-axis is the past and x-axis is the future. So we try to understand if we take one electrode from y as the past and if future as the electrodes on the x-axis, how the past influences the future or the electrodes on the x-axis. We can see the dark shade of red indicates that there is more dependency or there is more influencing from the electrodes or the pair of electrodes, and the lighter shades or the more blue color it is there, it shows that there is more distinction or less dependence. What if there is complete specialization in the brain? We wanted to understand how two electrodes or regions of the brain are distinguishable from each other. The Jensen-Shannon distance is a symmetric measure that measures the difference in information flow between two probability distribution by measuring distance of each probability distribution from the mixture of both. For example, if we have two probability distributions, prediction and baseline, we try to see how each one of them varies from the mixture of both. Smaller values indicate that there is less distinction, higher values indicate there is more distinction. So here, smaller values depicted by the darker blue color indicate there is less distinction between the electrodes of the brain, while the darker red and the lighter red color indicate there is more distinction between the electrodes of the brain. Are there different states of the brain? We wanted to explore if we could decompose the EEG signal. This is sort of a future goal to decompose the EEG signals by epsilon machines to show different states and the transition between these states. So why do we wish to do that? For example, if we have a social media bot which posts when it is mentioned and remains still when it is not. So we can see that there are two states, posting and staying still, and the transitions are it being mentioned or not being mentioned. So it captures the entire process in the form of states and the transitions. And these epsilon machines don't have any prior assumptions like linearity and help us to explore the different states of the system and their transitions. We then try to measure the statistical complexity, which quantifies the amount of information represented by these states. So our final goal is to calculate the information metric between different time series data and lay a comparative framework for finding technosignatures from the same by comparing different time series from outer space from the time series obtained from the Earth, thus bridging the gap between the both. That being said, this work was not possible without standing on the shoulder of giants. I would like to thank my parents for their motivation and my mentors, Dr. Stuart Bartlett, Dr. Jim Cleves, Dr. Anirudh Prabhu for their constant support and motivation. I'm open to questions and thank you. That will be it.